This is section 5.1, part 3. Now we want to graph polynomials using transformations. In section 3.5, we learn the methods of graph transformations, and we can use these methods along with what we've just learned about power functions to graph polynomial functions. So we have a visual now in our mind of what the even functions look like and how they behave, and what the odd functions look like and how they behave. So we want to use that information plus what we know about transformations to describe and graph these. So notice in example 2, we just want to describe what transformations are occurring from the parent function, and then in example 3, we want to actually graph them, the same two. Okay, so let's look at example 2a, and it says to use words to describe the graphs of the functions below as a transformation of the power functions y equals x to the fourth or y equals x to the fifth. So we'll look at A, and which one would it be, x to the fourth or the fifth? Of course, it would be the fourth. We can see that right here, and that's an even function, right? And so we will expect to see that behave like the evens that we just explored. Okay, so what transformations do we see here looking at this, based on this being our parent function y equals x to the fourth? Well, in any order, so you may see them in a different order that I do, but the first one I see, outside the function, I see this negative, so I'm seeing a reflection in the vertical direction, which means if you reflect vertically, you're going over the x-axis. So we will reflect over the x-axis. And to make that happen, what do we do? The x's don't change, right? When you reflect over the x-axis, x equals 2, x equals 2. What changes is whether y is positive or negative, right? Okay, so it's going to affect our y value. It's a outside the function transformation. Number 2, the next thing I see is this 2 here, and that outside the function means it's vertical. It's a vertical. It's a stretch. And it's by a factor of 2. Okay, and there's one last one. It's inside the function. That means it's a horizontal, and it also means that horizontal affects the x coordinates, and so we are going to shift which way? Left, good. 1 unit. Okay, so in other words, I've got my original x, y ordered pairs, and they will transform in this way. The only thing that's going to affect x was this last one, right? That's the only thing that was going inside the function. Left 1 means I'll take every x and I will subtract 1. For my y's, okay, I've got to reflect it over the x-axis, which changes y from positive to negative or negative to positive. That means multiply by a negative 1. But I also have to multiply by 2 to stretch it. So multiplying by a negative 1 and 2 means I'm going to actually multiply by negative 2. So take every y value and multiply it by negative 2. And that will get the new coordinates for my transformation. Okay, well, let's come down here. Let's just go ahead and come down here and graph that. So what are our original points on the y? Remember, the parent is y equals x to the fourth. So let's graph that. Let's see if I can switch to a pencil and you can still see it. Of course, we're at 0, 0 for our parent function. 1, 1, negative 1, 1. And then what, 2, and what's that, 16, and I don't have 16 on here, so I'll just have to do my best to graph this, right? Not very good, but you get the idea. Okay, there's our parent function. All right, but we're going to take these points, and we'll just work with those 3 that I was able to graph. So I'm going to take the point going back up here 0, 0. And what are we going to do to it? 0 minus 1, negative 2 times 0. So the new point is negative 1, 0. And I have the point 1, 1. And I'm going to use 1 minus 1 and negative 2 times 1. And my new point is 0, negative 2. And then we had negative 1, 1. We'll transform. Negative 1 minus 1 and negative 2 times 1. And the new point is negative 2. Negative 1 minus 1 is negative 2. Negative 2. Those are our three new points. Okay, negative 1, 0. 0, negative 2, and negative 2, negative 2. So what we see, as we expected, we reflected over the x-axis, we shifted left 1 unit, and we should see a skinnier, a more stretched version. Of course, you know, my freehand drawing maybe doesn't illustrate that as well, but that's what we have. Okay, that was our even function. We said the other one, we noticed this one's to the 5th power, so the parent is y equals x to the 5th. Let's see if we can tell what our transformations are. The first one I see here is outside the function, we're multiplying by a half. So this is a vertical compression by a factor of 1/2. What's next? What do you see next? Well, inside the function, we have a horizontal shift, right? Or shift, which way, left or right? It's -2. Right, very good. Shift right 2 units. And what does that last little +1 do? Well, it's outside the function. Shift up 1 unit. Okay, again, the only thing that was inside the function was this one, number 2. That's the only one that affects our x coordinates. All right, so we'll take each of our parent function coordinates, and to x, we will add 2 units. To y, we have to multiply by a half and go up 1, and of course, which would we do first? We will multiply and then add 1 to get our new coordinates. Let's see what the original ones would be. Of course, with the parent function here being y equals x to the 5th, we put in 0, 0. We put in 0, we get 0, right? For x to the 5th, you put in 1, you get 1. X 1 to the 5th is 1. Negative 1 to the 5th is negative 1. And 2 to the 5th runs us off the page. So let's just do our best. We know kind of what this thing looks like. All right, there's our original parent function. And we have those 3 points that we're going to try to transform. Our 3 points were 0, 0, and 1, 1, and negative 1, negative 1. Okay, so we'll take 0 plus 2, we'll multiply 1/2 times 0 and add 1. And our new coordinate here is 2. Half of 0, 0 plus 1 is just 2, 1. 1 plus 2, 1/2 of 1 plus 1. 1 plus 2 is 3. Half of 1 is a half. Plus 1 gives us 3 halves, or 1 1/2. And now we have negative 1 plus 2. And 1/2 times negative 1 plus 1. And what does that give us? 1. That's negative a half plus 1, so a half. All right, let's see where we are now. 0, 0 moves to 2, 1. 1, 1 moves to 3 and 1.5. And -1, -1 moves to 1.5. So you may not be able to tell it, but it's a little flatter, as though it's been compressed vertically. The original one pressed down on and compressed vertically. Okay, we will continue in our next video.